All right, functions and models. Now, you kind of got to go back with the idea of what is a function. A function in this meaning is just simply something that you do. What is the function of a light switch? Turn a light off, turn a light on, right? Okay. So if I go back there and I turn those light switches off and on, it just turns the lights on in this room, correct? Doesn't turn them off in Mr. Johnson's office, does it? Kind of freaky though, turn the light switch off. I mean, I couldn't hit one of those switches and have the water fountain go on, would I? Maybe I could, but that's not the function of that particular thing. So when we're talking about functions, it does a certain thing in a certain place, okay, given certain conditions. That's all that it really is. And the thing is, once you've got this idea of a model going on, it's just simply based upon a function. Something is happening. How does it work? What is the result? What goes in? What comes out? Same idea. So functions and models are very, very much the same thing. So if we take a look at this idea down here, it says function definitions, okay? So we can do a lot of things. We can make a chart. I can make a graph. I can put a line on it. I can do all kinds of wonderful things for it. It's just that what does this mean for us? What does it do? Now there are two things that you are definitely going to have to come in and remember. Domain and range. Domain is what goes in. Last two letters, I-N. Domain, in, input. So when I go back and I use the light switches back there, what is the input? What's the input for a switch? On, or that's the state that they're in, but what's the input? What's input? What's the input for the light switch? The what? Gotta speak. Flipping, turning the switch. Me going over there and actually moving it, that's the input, correct? What's the domain? What's the outcome? What do I expect it to do? Turn the light on or off. Okay? Didn't do anything with the electricity, did it? Didn't say anything about that. That's not the input to the light. The input is going to the switch, up, down. Those are the only two possibilities. So the output or the result of that is going to be either the light turning off or the light turning on. That's all it is. Since in that case there's only two possibilities, right? So like I said before, these beige boxes, make sure that you get this information and you know what it is. Now, it says a function is a rule or a correspondence that assigns each element of one set, called the domain, exactly one element of a second set, called the range. A function may be defined by a set of ordered pairs, a table, a graph, equation, or a verbal description. Basically, if I put this in the simplest terms possible, one thing in, one thing out. Okay? If I do something, only one thing should happen. That would make sense, right? And after all, if I go and ask for, let's see, if I say, Terrence, I want you to do something, how many people here are going to respond to Terrence? Say one. Okay. Now, if I had all my freshmen together, and I got a Tristan in spot 4 in both of them, right? So if I had all of my freshmen together, periods 5 and 7 were together, and I asked for Tristan, would I get the Tristan I wanted? Maybe, maybe not. Because I got two of them there. There's two possibilities. There's two ways to respond. We only want one thing in, one thing out. So, let's see here. Let's continuing on. So, what we want to do is we want to think of this idea as a function, as kind of a machine. Speaking of machines, you guys know of this wonderful invention they call a toaster, right? What does it do? Toast what you put in, right? So if I put in a piece of bread, I get a piece of toasted bread out, right? If I put a Pop-Tart in, I get a toasted Pop-Tart out, right? Could I ever put in a Pop-Tart and put it down and out pops a steak? Is that going to happen? No, because that's not the function of that particular machine. And the only way I would get a steak out of a toaster is if I put a steak in the toaster. That'd be kind of a messy situation, would it not? So it's not something that goes into that function. So I suppose I put, ooh, those toaster strudels, those are good too, aren't they? They work. So when we're dealing with a function, we have to take a look at what is possible to come into it. We just can't put anything into it more often than not. So that's where, again, this idea of domain and range comes from. So functions with variables in the denominator may have an input value that gives zeros to the denominator. To find values not in the domain, set the denominator equal to 0 and solve for the variable. Okay? We got to be careful about this. Generally, we could put any number we want in, but if there's a number that makes something go bad, go wrong, not correct, bad numbers, like division by 0. Division by 0 isn't a good thing. Functions with variables inside an even root may have one or more input values that give negative values inside the even root. To find the values in this domain, set the expression inside the even root greater than or equal to 0. Solve for the variables. If you've got something squared, it's equal to something squared. There's always two possibilities, the positive and the negative. So, all of these things are wonderful ideas to keep in mind. So let's take a look at this. That there we go. So I've got y is equal to 4x. Okay? What is it? Well, as we go through this, you'll recognize that this is going to be a parabola. And if we do what we used to do, we just kind of pick numbers to go in for it. So if I make an XY table, and if you remember from algebra, I said at least whenever you're doing an XY table, there's three numbers you should always try and put in. 1, 0, and -1. Okay, those kind of give you kind of an idea of what's going on there. So what happens if I put 1 into this? What do I get out? 4. What happens if I put 0 in? What do I get out? 0. What happens if I put -1 into this thing? I get 4. Is that legal? Will that work? Is that a function? The thing about a function is I put one thing in, I get one thing out. So if I put in 1, will I always get out a 4? Is there any possibility of me putting 1 in and getting something different? No. What about negative 1? If I put in negative 1, will I always get out 4? It's the only possibility that I have for this. One thing in, one thing out. So that's legal. So far, so good. So, let's try this one. Let's see if there's any problems with this one. Okay. So, I'm going to do the same thing I did before. I'm going to pick on my x and y, and I'm going to put in 1. If I put 1 into this, what number do I get back out of it? Well, 1 goes into x, so 1 minus 2 is going to be negative 1. 1 divided by negative 1 is negative 1. Negative 1 plus 1 is 0. Okay? What happens if I put 0 in here? Okay? Well, if I put 0 in there, 0 minus 2 is negative 2, so 1 over negative 2. Okay, so that's going to give me, that should give me positive half. Yes? Okay? If I go and put in the negative 1, I put in negative 1, I get negative 3 on the bottom, 1 over negative 3 plus 1, so that gives me 2/3. Okay? Must work for all the numbers, right? Because I checked my 1, 0, and negative 1. Unfortunately, those are perfectly legal values. But I've got a problem. What happens if I put this value in? I put in 2. What's 2 minus 2? And division by 0 is? Come on, I had you guys mostly trained for this 2 years ago. Division by 0 is? I hear a little undefined. Division by 0 is undefined. You got to say it with gusto. Come on. Don't look at me like that. Because 9 times out of 10, when I say division by 0, people say 0. And that is the incorrect answer. Division by 0 is undefined. There is no answer that I can come up with this one. So this one here, there's nothing. You can't put anything in here. So now when we're doing our problems, we have to kind of sit there and look and think, what can I use? What can I not use? Let's try this one here. Okay. There goes here. So I'm going to do the exact same thing I did before. X and Y. I put in 1. Well, if I put 1 in there, what's 4 minus 1? 3. Can I find the square root of 3? Is the square root of 3 a legal number? Sure it is. Absolutely, perfectly legal. What happens if I put my 0 in there? Well, what's 4 minus 0? What's the square root of 4? 2. Perfectly legal. What happens if I put in negative 1? Well, square root of what? 5. Hey, looks like I can put any numbers in there I want, right? You would like to think that, but you're wrong. Is there a number that's going to cause us problems? Yes, sir. 4. Okay, so if I put in 4, what's 4 minus 4? What's the square root of 0? The square root of a number means that two numbers exactly the same multiplied together equal that. So what number would work? 0. But you're on the right track. What happens if I put in 5? Because now 4 minus 5 gives me negative 1. What's the square root of negative 1? Nothing that you know at this time. Okay? So this is why it is so very, very important to understand what our domains and ranges are going to be. So rather than going through and writing out like this, what we want to do when we're identifying domains and ranges is what numbers can I put in, what numbers can I put out. So I want to think in terms of domain and range. Domain is what goes in. So I ask myself the question, looking at A, is there a number that I cannot put in there that will not work? And just a quick look at it goes, no, I think I can put in a positive, I can put in a negative, everything works. I don't look for nothing that makes square roots go bad or division by zero. So this would be all reals. Okay. Now, what about the range? What goes out of this thing? Okay. This is, again, where we want to look at positives, negatives, and zeros. Okay? If I put a number in here, will I always get a positive out? Positive number in, positive number out, right? If I put in 0, what do I get? If I put in a negative number, what do I get? Positive. So, this would end up being non-negative reals. Or we would just say non-negatives. Now, the reason why I didn't say positive on here is 0 a possibility. If I put in 0, I get out 0, perfectly legal. 0 is a possibility. Is 0 positive? Nope. Is 0 negative? Nope. So, that's why we go and say that it is non-negative. Okay? Because it's not a negative. Now, B. Think about this one. Domain and range again. Okay. Is there a number that I cannot put in here? And what number would that be? 2. Why? Because 2 minus 2 is 0. And division by 0 is undefined. Ah, we're getting closer. So, we would say that the domain here is all reals except, although I'm not going to write the word except, that's always too long, all reals, but we would state that x cannot be equal to 2. So, we can have all reals again, except x cannot be equal to 2. So I've identified what numbers I can put out in here. Now, what about the range? What kind of numbers will this work for? Now, sometimes you're going to look at this and say, oh, well, gee, that 2 is kind of a problem in there. Okay? If we were to go and take the graphing calculator, and I were to go and put this particular one in, there we go. So turn that one on. Y is equal to, clear that out of there. And I were to go 1 plus, and then 1 divided by parentheses x minus 2, close it, and I tell it to graph it. Okay? What we are going to see here is there's this little line here that's a hiccup. Well, unfortunately, with the older graphing calculators, that's what we get. Let's try this one. This one should be the wakey wakey. There you are. Okay. Clear. Y is equal to, put the same thing in here, 1 plus 1 divided by parentheses x minus 2, close it, and I hit graph. Okay, thumbs up. There becomes a point of what's called discontinuity. I can't put 2 in there because it's going to cause me difficulties. Okay? Now, this is kind of where we start thinking about what's called end behavior. Where does this thing go? Where does it come from? if I put a negative in there for x, okay, what kind of values will I get out for that fraction? Will they be positive or will they be negative? I'd get negatives, right? If I think about this, this is going to give me what? If I put negative 1 in there, that gives me negative 3, right? If I put negative 4 in there, that gives me negative 4. So this fraction, as this x gets larger, meaning a larger negative number, bigger on the number absolute value stuff, what happens when the number in the denominator in the fraction gets bigger? The fraction itself gets smaller, doesn't it? So eventually this thing is going to go towards 1 somewhere out there. But it's going to be subtracting a smaller and 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 smaller pieces, right? What about on the other side? If I keep giving it bigger and bigger and bigger and bigger numbers, again, that fraction keeps getting smaller. It keeps getting closer to 1. Okay. Now, what we would be looking at here would be, would be all reals. Okay. Except there's going to be a line that it doesn't cross in there. So all reals, but we don't know what that is yet. Okay. We haven't figured out how to go and find that yet. But does it look like it would be possible to have every single one of these numbers in them? Okay. That goes up to 1. The other one adds, going away from 1. Is it ever possible to get 1? No. So, all real, but now that we sit there and we look at it a little bit, could I say y is not going to equal 1? Because can you think of a number that I could put in there for x that would make me go to 1? Now, the only thing that would help, that would add to it, would be a 0, right? 1 plus 0 is 1, correct? But is there any way that that second term is going to become 0? No. What about the next one there? Domain. Range. Is there a number that I cannot put into here? Well, before we've seen that the number 5 didn't work, right? Would the number 4 work? Anything bigger than 4 will not work. 5 is bigger than 4, right? So when you're looking at this, you've got to be able to think about numbers really close to it, but not it. So when I think about the number 4, I can think of numbers just a little bit smaller, 3.999999999999999999999. It's close to it, but it's not 4. What about bigger than it? Like 4.0000000000000000000000000000001. That's a little bit bigger than it, right? Would that work here? No, because you'd have the square root of a whole boatload of 0 and then a 1, right? It would not work. So we say here that the domain is going to be x greater than 4. Or if we go and put it into the notations that we were looking at before, it would be like this, parenthesis 4, comma, infinity. And your infinities, by the way, is sideways 8. You've got to learn how to draw those things out. What would the range be? Okay? So my question is, what is the smallest number that I could get out of this thing? Well, the smallest number I know I can put into it is 4, right? Okay. Oops, I screwed up. You see it? What did I do? It's supposed to be less than 4. I said, because I put into it what cannot be, right? I got to change it and put in what it can be. So I really should have x is going to be less than 4, which makes it look like this. Oops, sorry. Negative infinity, comma, 4. Is that better? Okay. When you see things like that, you gotta say something. Okay? Pay attention, follow along. So what about the range? If I put in a 4, I got 0, right? So y would be what? So would it be this? Or, more specifically, that. It takes a little bit of time to sit there and look at what's domain, what's range, and to play the mental gymnastics to figure it out. Graphing calculator can help. It just takes time to go through and do these things. So, domain and range. Tests for functions. Okay. If I take a look at this, A is a function. If I take a look at the first one there and I say, where does 2 go? 2 goes to what? Does 2 always go to 3? Yep. 5 always goes to 4, -1 always goes to 1, 7 goes to 14. I could care less how they calculate the numbers. I just know that that goes in, that's what I get out. Okay? So, what about the next one? 4 always goes to 7. Ooh, where does 8 go? 8 goes to where? You can only give me one answer. Where does 8 go? Oh, you already know the game, because if you say 6, I'll say 9, right? And if you say 9, I'll say 6. That's why it's not a function. One thing in, one thing out. And see, this is where computers come in play. You want to put one thing into a computer, and I care less what program that you're doing. You want it to do one thing and always come out with one thing. I mean, it wouldn't be very good on a keyboard. Be a nice hack, you know. Sometimes you hit A and it comes out as an A. Sometimes you put in an A and it comes out as a Q. Sometimes. That'd mess people up. So, what about the next one? Is that a function? Yeah, but 6 has 2 things on it. If you look at 8 had 2 things on it before, right? If I ask the question, where does 2 go in C? 2 always goes where? 6. No matter what I do, I put a 2 in and I get a 6, right? If I put a 3 in, I get a 7. If I put a 4 in, I get a 6. So what? As long as I know that if I always put in that 4, I always get out that 6, I'm happy. Okay? Because after all, when you ask for something, you want to get what you ask for, right? It's not fun when somebody just goes and automatically, oh, I'll change my mind and give you something else, right? That's no fun, is it? I mean, if you think about it, McDonald's, drive-through, it's a function. You go and order, you go and pay, that's your input. Do you expect the appropriate output? Yeah, not a problem. So that's one of the things you got to look at when it comes to dealing with things as a function. Okay? So, is that a function? If I take a look at A here, is that a function? see your head's nodding either yeah or no. Right? So if I ask you how many computers are sold in the year 2000, will the number change? Will it always be 16,400 million or millions of dollars? Yeah, that's not a problem with that. Let's try. Think about B. Okay, daily profit in dollars from the sale of X pounds of candy. Would that be a function? Would that be a function? I mean, if you sell, 20 pounds of candy, will you always get that profit on 20 pounds of candy? No. Number of tons of coal sold determined by the profit that is made from the sale of the product. Okay? So, is that a function? If I sell absolutely no coal, I lose $100,000, right? I mean, there's no situation where once I sell 2,000 tons of coal and make 480,000 and sell 200,000 tons of coal again and only make 109,000, right? Doesn't happen according to the chart. Okay. What about D down here? A person's weight in pounds during the week of a diet. So, you're on a diet, you're weighing yourself each week. Okay? Well, is that going to be a function? So if I ask you what your weight was in week 1, which one of the measurements would you want to provide me with? Would you not want to provide the number that made it look like your diet was succeeding? Yeah. Would your weight be the same on Monday as it is on Tuesday, as it is on Wednesday and Thursday and Friday? Well, you might have a couple of days in there that give you the same weight, but the probability of that event occurring is extremely low. So, by going and setting a person's weight in a week, would that necessarily give you a function? Okay? So you got to be kind of careful about some of that stuff. Okay? So, let's see. So if I take a look at example 4 here, if I have y squared is equal to that, does that define y as a function of x? What do you think? What kind of a graph would that be? What's messing things up right now? Or that looks weird to you? What? The square. Where's the square on? The y. We usually don't see a squared on the y, do we? See, that would, if we were to go and simplify that one, we would end up having to say y is equal to plus or minus the square root of 3x minus 3. Okay? I would have to do that so that I would be able to see what's going on here. So, if I were to do that, and if I were to put in the same value for x, one would come out as a positive, one would come out as a negative. Not a function. What about b? Is that a function? Yeah. Another way of looking at it is if you can put it into the graphing calculator as a y equals, you've almost always got a function. Okay. What about down here with C? They got a graph here. Okay. So, is that a function? Can I look at, say, Can I guesstimate where August 10th is and figure out how much money Home Depot made? So if I look at this one right here, how much money did Home Depot pull in? I don't know. It looks like it went from like 32 to 34,000 or 32 to 34, whatever that is in dollars, right? Probably stock share price. So, is that a function? And the answer would be no. We got to have one specific answer for a specific input. Okay? Now, this is usually the best thing to do whenever you got a chart. Vertical line test. If a graph can have a vertical line drawn anywhere on it, and it hits it in more than one spot, not a function. Now I realize that, well, gee, I could probably move this back over here and it would hit it in one point. But if I put in 4, which one do I get? 3 or negative 3. So the vertical line test is generally what we use. We take a look at that, and if I can draw a vertical line and it hits it in more than one spot, not a function. So if I go back to this idea, to that idea with the Home Depot thing, all of those are what? Every little mark that's in that graph is what kind of a line? It's a vertical line. I mean, it already fails itself for the vertical line test because they're not points, they're vertical lines. I draw a vertical line on it, it'll hit it in more than one spot. Okay. So, if I look at this one, that works fine. Anywhere I draw that vertical line, it only hits the graph what? In one spot. That's all it will do. Okay. Now, one of the things that we use around here is called function notation. Introduced this a little bit when Algebra 1. It says y equals f of x. And we definitely like using that. That's good old Euler's notation. Euler's around here someplace. Where's Euler? Euler's way back over there in the corner. He's the one that kind of went through and took everything that was here and kind of compiled it. Everything from here all the way up to him, kind of compiled it into something that was more manageable. Okay? Made things easier to deal with. So when you got problems, just blame Euler. It's all his fault. But Euler's notation or function notation, what this tells us is whatever function we've got, so we've got a label now. Because if you think about it, all those equations we had, y equals this, y equals this, y equals this, how do you tell them apart? You really couldn't. Because one might be y is equal to x squared, the other one might be y is equal to 2x squared. How do you tell the functions apart? Is there a name? Is there a label? Now we can do that. I could have f of x, I could have g of x, h of x, I can have whatever I want to call it now. The variable always stays the same. This tells us what the domain variable is. So right here, this is telling me that every place I see x, I replace it with a 3. Here I replace it with a 1. It's just telling us what goes into. What goes into. So, is there anything else that I want to deal with here? Now, to be perfectly honest with you, I know that you guys can add, subtract, multiply, and divide. I know that you know how to use powers. What we need to do is start taking a look at the interpretation of what it is that you see with your math. On, silly piece of. So, what I would recommend, graphing calculator. Now, mind you, you can use a spreadsheet if you so choose, but graphing calculator is by far more interesting to be able to use. You can plug this in. So we would take 2x, raise that to the third power, and we would take 5x squared. Put my plus thing over there. Plus 5x squared minus 28x minus 15. And if I graph it out, I get some weird looking stuff. Okay? We wanted to find -2 and -4 on here. Well, if I wanted to, I go second, I can go to table. 4, what value is 4? 4 is 81, right? I can go up here, -2 is 45. We can change the windows, we can adjust a lot of different things on this thing. I showed you that when we were in Algebra 1. Don't worry, we will go over it more. Let's see. Don't believe I need anything else other than no mathematical models. Now, mathematical model is nothing more than a formula. Something that describes how to get somewhere. A recipe for baking. It's a formula. It's a model. It's a set of procedures to go and do something. That's all it is. Okay? So this one here, Fahrenheit to Celsius, or Celsius to Fahrenheit. I can adjust that so I can figure out each one. So that way when we go a little bit further north, we know what the temperature is. Okay? Or so Phileas doesn't get completely blown out of the water when I say it's 40 below. Which 40 below to him would be a lot colder than 40 below to us. Okay. So, let's see. I don't think there's anything else that I want to cover. So there we are to the assignment. And I'm going to be quiet and let you guys get to work.